We are live. Welcome everybody to this webinar about using DuckDB in your data pipelines. I'm Kris, I'm the founder and CEO of DataMinded, and I have a true expert here with me. Niels, if you can introduce yourself.
Thanks, Kris. Well, I'm one of the lead data engineer at DataMinded, and I've been working with DuckDB and DBT within our product Conveyor. So that's why I'm here, just to showcase how I think it could be used. I also wrote a blog about it a couple of months ago, where there was quite some traction and some interest. So let's dive into that topic again this webinar.
Indeed, yeah. The blog you wrote caused a lot of interest indeed, and it shows that there is a need in the market for something like DuckDB, where people are at least interested to see how it fits into their architectures and stuff. So the main talk today will be done by Niels, so I'll let him share his screen in a bit and let him showcase everything he has to showcase. But before we do that, we're going to make this a little bit interactive. So first of all, let me know if you can hear us well, if you can see us well. You can use the comments on YouTube or LinkedIn or wherever you are. I should be able to see them. And we also prepared a Mentimeter for you. So I'm going to add that to the screen now. So if you go to menti.com and use the code 78467142, we're going to ask a few questions. So I give you some time. There's a bit of delay in the stream. So I'll give you some time to go to menti.com and enter that code. Okay, Jan can hear us. Awesome. Hey, Jan, it's been a while, by the way. All right, so go to menti.com 78467142, and we'll ask a few basic questions before we get started. The first thing, if you haven't got the instructions page completely yet, you can still see it at the top. So go menti.com 78467142. And the first question we asked today is like, what do you want to get out of the webinar? It can be free text. What do you hope? We have about an hour together, so what do you hope to get out of this in about an hour? Give you some time to answer this. Yeah, there might be some delay. It takes a bit. Yeah. In the meantime, I hope you can appreciate our nice ties that we bought for the occasion. All right. Let's wait until the answers come in. Niels, maybe while we wait, can you share how you got to know DuckDB for the first time? Do you remember? How you got in touch with DuckDB?
Well, yeah, it's been quite popular over the past, let's say, 6 months. So there were quite some blog posts out there. But the first real connection came when they did a small conference in Brussels. I think it was end of January or February, where I got to know it a bit better and also more technically, and then I thought, well, okay, there might be something there, and that's actually the first start where I really start playing around with it and see how it could fit, which use cases could it solve, and then I think, well, okay, it might be a good fit in certain areas, and that's got the ball rolling, and then I did the blog post and then discussed it with colleagues here in DataMinded. And I think, yeah, it's really nice tool, and it's a good thing to know, to have it on your belt for certain areas and certain projects. It really makes sense.
Right, cool. At the same time, I still don't see answers coming in, so I'm going to check Menti myself to really make sure that it's working. Else, yeah, we're going to move forward. So guys, don't be shy. If you have something you want to get out of this, you can post it now. All right. Well, if not, let's move to the. There are already 11 answers. I just didn't see them yet. So let's go over them. The pros and cons of using DuckDB plus DBT versus Spark. Deployments and tips in introduction to DuckDB and what additional value it brings. what DuckDB is and how it fits in the pipeline landscape. Should my team switch all Spark pipelines to DBT and DuckDB? Yes. Always.
Yes, there's only one right answer there.
How to leverage efficiently DuckDB and DBT in a lakehouse. Get informed about DuckDB. Does it come with DBT plus DuckDB giving me the same level of tools as another language like R or Python? And that's a good question. Isn't it more of a niche? Because indeed, I'll let Niels give you the real answer, but it won't solve all the things that you can do with Python or R, right? So advantage of DBT over ADF plus Databricks pipeline. More arguments to convince IT not to use Spark for medium-sized data. Yeah. I hope we can give you some ammunition here.
Yeah.
Learn about applying DuckDB plus DBT to smaller scale projects as well as about possible cloud deployments. Performance comparison with Spark would be nice. Hardware minimum requirements for optimal DuckDB usage is also a good one.
Yeah.
And to be clear, today we're going to talk a lot about DuckDB. We're going to compare it a bit with Spark. That's not to say that Spark isn't relevant anymore. Right? Like, it's one of the most popular big data processing frameworks. It's super powerful. It's super versatile. You can do a lot of things with Spark. We use Spark in a lot of our clients. It's just like everything. It's not the perfect tool for all the time for every use case. And with something new like DuckDB coming on the scene together with DBT, it just gives you more possibilities, not less, right?
Yeah, it's exactly like that. It's just another tool you could use, and like anything in data engineering or software engineering, it's a trade-off. You need to know in which use case it doesn't make sense and in which case it doesn't, and that's also a bit what I want to talk about today.
All right, cool. All right, then let's dive back to the questions. Sorry, there we go. Sorry. Okay, I'm also going to keep open a Q&A. So if you go to menti.com, you should be on every slide, you should be able to ask us anything. So if you have questions, just post it here. I think you can also vote on questions, and then we can answer them at the end of the webinar. So just as a reminder that this page is open. For the next question, we're curious about which other technologies you use besides DBT. Well, DBT is one of them. So you use Spark today, you use SQL for your data transformations. Use DBT, Bandas, Polar, something else. So you can vote on, and I think you can choose many options here. Okay, so the first are coming in. I think also from our experience, we use quite a few of those depending on the use case at the client. So All right. So it's a bit of a mix. Quite a few people are using Polars. I'm a bit surprised. It's so popular.
Will be Jan voting 3 times from data-minded.
Yeah, SQL is a big one. I like that as well.
Yes.
Okay, Pandas. Okay, 5 others. Yeah. Okay, that starts to make sense. I also skipped this question, so I'm going to go back to this. What is your experience with DuckDB? You don't know anything about it yet. Did you read some things about it but never used it? Did you already play with it, or are you already using it in production? Specifically curious if someone is already in prod with DuckDB.
Yeah.
That would be cool. All right. Okay, yeah, that makes sense. All right. So it's on the radar for most of you. And some of you have played with it, but not really in production yet. So which is fair enough. I mean, it's still recent technology. Here the votes as well. Again, so a lot of SQL, Spark, and Pandas.
Mm-hmm.
Okay.
Makes sense. That's what we expect, I think.
All right, I'll keep the Q&A open. But with that being said, we're going to switch gears now, and we're going to go back to Niels. So Niels, I'm going to add you to the boom. I'll remove this. Yeah. All right, Niels, with that being said, the floor is yours.
Thanks. So before diving into DuckDB and DBT, let's take a step back and look at a typical batch ETL architecture. Right? And I think roughly these components are always there if you create this type of architecture. And then you see on one side you have your operational system, a couple of data sources to do your actual business value of your company, interact with your customers, etc. And then you want to do analytics on them. You typically don't do that on the operation system itself because you don't want to burden them. You also typically, those databases are not well suited for these large aggregation queries. So that's why you want to move it to a data warehouse, either a data lake, and then this type of flow flows out of it. So typically start with an ingest component, pulls in the data, and copies it basically to your data warehouse or data lake, depending on what your preference, what exists, or if it's very clear already, what are the use cases, what's the model you want to use. A data warehouse might be a better fit, otherwise a data lake is a good way to start from. And then in this webinar, I mainly want to start not the ingest part, but the transformations. And we're going to talk about, okay, we have our data, we have our raw operational system, we want to aggregate, we want to do some analysis on them, we want to ask some questions and then derive some insights from this data. So we want to combine multiple data sources together and clean up this data to be able to present it to either internal customers or also externally within the company. Could be with a dashboard, could be with a custom application, an API, or whatnot. Within these transformation, well, you typically, I see there are three major players there. So you have SQL or DBT, you have Spark, and Bandas or Polars. And in this start, I want to focus a bit on what are the trade-offs there, what are the pros and cons of each of these technologies, and where does DBT and DuckDB fit in which use cases does it make sense and which not. So let's start. I created this for a very simple flowchart where I would say, well, what is the natural way where I position the different technologies? So the first question I ask myself, is the data already in a data warehouse where I want to do some transformations? Well, if that's the case, well, use DBT or just plain SQL. I think most of you already do that. That's not the topic of this talk. In this talk, I want to have it more on data lakes. So let's say you have a data lake, you have some raw data, you want to do some processing on it. Is this data that you want to process really large? Means a couple of hundreds of gigabytes, terabytes of data. Well, the go-to way is then Spark, and it still is. It's very good at distributing these computations. You can distribute it across multiple machines, which means you can use relatively simple or cheap machines to process a lot of data. So what are the other advantages? Well, of course, you write code, you write Python, you write Scala. It's composable, you can create functions, you can reuse it. So in my opinion, for complex transformations, it's well suited and it's still maintainable. Also, a big advantage I find is that it has a really good integration with a lot of the different data formats, Avro or Parquet, but also the table formats if you want to use Iceberg or Delta, etc. Those typically come quite out of the box with Spark. Of course, with...
Niels, I think when you go to the next slide, we don't see the next slide. We still see the batch ETL architecture slide.
That's weird.
Yeah, maybe if you present again now, I don't know.
That's not good.
Can you go back and forward now? Oh, it's frozen. Yeah, so maybe just don't.
I just don't use the share screen. All right. Okay. Sorry about that. So any technology has its downsides. So what are the cons, let's say, of using Spark? It's difficult to manage. Difficult to manage. The infrastructure you need to set up to be able to execute these Spark applications is quite substantial. Of course, with EMR and Databricks, it's becoming easier, but still you need to manage quite some infrastructure. And that's one part, but also creating the Spark job is non-trivial. You have a lot of knobs and whistles which you can turn when creating a Spark job, when optimizing for efficiency or for throughput. But it takes a long time to really understand how it works and know which knobs and whistles to turn. So it's a really experienced job, which is required if you want to process a lot of data, but I don't think it's required if it's small or medium-sized data. So the number of people who can write efficient Spark job is limited. It's far less than the number of people who can write SQL. That's why I say a smaller audience. And since Spark is tailored to distributed mechanism, if you want to process a small amount of data, if you only want to use one or two executors, typically it comes with quite some overhead, which is may be unwanted. You could say, well, we standardize on one tool and that's fine. But you could also say the overhead might be too large, and maybe Pandas or DuckDB or DBT could be a better fit in that case. So let's then go to the next technology. It's Polars or Pandas. I'm combining both of them since, in my opinion, the pros and cons are similar. And with Pandas, I really look at certainly the new version, 2.0, which uses a pi-arrow format, which brings a lot of advantages compared to the Polars 1.0. What is the focus point? What is good about this? It's a lot more simple to reason about. Right? You have one machine. It has a certain amount of memory. It has a certain amount of cores to do the processing, and it's just that. You don't need to think about, well, I need to shuffle data across different machines, etc. No, it's simple, and easier to write in that sense. Yeah, you write code. Again, you can abstract it away as you want, and you can compose them. What are then the cons or the trade-offs? Well, since you have a limited amount of memory in your one machine, typically the data sets aren't as large as you could process with Spark. Now with the 2.0 and the vectorized engine and pi-arrow being behind it, it's not that your data set is really limited to the amount of memory, because certain operations can be batched and written to disk already intermediately, but there is still a limit. Certain operations are still very expensive and impossible to calculate. What I also find a bit of a con with Pandas is that it comes with a lot less integrations. You can install Pandas or Polars, for example, but to integrate it with a blob file storage, for example, you need another tool. And that makes it more difficult to manage, also to understand for certain people. And again, it reduces the audience that can work efficiently with it. And so we had large volumes to use Spark. If you want to use Pandas and Polars, if the primary users of or writers of your data pipelines and managers of your data pipelines are data engineers, have really a programming background. But if that's not the case, if you want your data analyst also to be proficient within those pipelines, then I think DBT and DuckDB might be a good niche and a good fit to use. And why do I think that? Well, again, similar to what Polars and Pandas provide, it's simple in execution. You have one machine, a certain amount of memory, some CPU cores, easy to reason about. You just write SQL code. So the primary thing you do is just writing SQL. And it comes out of the box with a lot of integration with Parquet, integration with blob storage, etc. So you don't need to install a whole bunch of dependencies before you can start working. I'm going to illustrate that a bit later. Of course, every technology has a downside. Again, the amount of data you can process is limited. You can't process hundreds of terabytes of data on a 32 gigabyte machine. That will not fly with DBT and DuckDB, but that's also not the point. It's for medium-sized or small-sized data sets. And then a last con, which is, well, not really handled yet or doesn't work very well. If you want to integrate it with Iceberg, there are some workarounds, but it's not really clean. But the maintainers are working on it, and it will come soon, at least in DBT and DuckDB adapter, which I will talk on a bit later. Okay, so that's a bit of the context. Where does DBT and DuckDB fit in, and which use cases you could use it, and when you shouldn't use it. So then diving in a bit deeper in what is DuckDB. If you go to DuckDB.com and you see the intro slide, it says DuckDB is an in-process SQL OLAP database management system. Okay, so what does this mean? It's an in-process database, which means it runs together with your Python code, together with your Java program you're executing, which is not to be confused with an in-memory database. And in process, it can be in memory, but it can also flush data to disk. So it's not limited to the memory you give to that process. Which is an important distinction, in my opinion.
But it does mean that if the process dies, the database dies.
Yes. But since you can persist it to disk, you can, if the process come back up and uses the same files, then your data is still there. But indeed, so it belongs to that process. It's an online analytical database, by contrast to the transactional databases used in operational systems. So it typically works column-based instead of row-based.
All right. I see a question coming from Danny. So what do you mean by limited? I'm not sure when you said limited.
The amount of the data you can process. Well, I mean limited in the sense I can't give a hard limit. It's not that previously, if you could say, well, if I want to process a data set of 60 gigabytes and I only have 32 gigabytes in memory, then I can't pull this all in memory at once. Okay, but typical the databases now, but also Polars 2.0 are not that stupid. If you do a filter and your filter condition is reducing your 60 gigabytes of data set to 20, then it fits in memory. So it's not easy to say this is the amount of data, but you will see that if your data sets increase and you have a small machine, that at some point your database will go out of memory.
Maybe if I can give a ballpark figure, but I don't know if you agree with that, but I would say if you talk about gigabytes of data, like, or maybe tens of gigabytes of data, I would consider something like DuckDB. If you talk about hundreds of gigabytes or terabytes of data,
or either you use a very beefy machine, but then the costs also skyrocket quite often. So indeed, I think in my rule of thumb, if the data you want to process is under 100 gigabytes, I think DBT and DuckDB in most cases will do very well. If it's above that, then I would consider other technologies.
And the thing is that even if you have big data in your company, then still, in our experience, there's like 2 or 3 data sets or terabytes, and all the other 100 data sets are like gigabytes or even megabytes, right? Which is fine. Right? So that means that yes, you have a large volume of data, but still 90% of your data sets would be able to be processed by something like DuckDB, right?
Yeah, that's indeed what we see. Yeah, that's correct. All right. I hope that answers your question.
Yeah.
So the third step is it's a database management system. What does that mean? Well, it's not just a database. It also has operations to create new databases, manage databases. So that's all it means. And then, so that this is, well, very nice and well, but what are for me, the 3 key features why I think DuckDB has a niche or needs to be considered? So first, it's the vectorized query engine. I talked about that before. It's the same mechanism as Polars uses. It's the same mechanism as Bandas 2.0 uses, which means it's a very efficient way to do computations. You don't need to pull all your data set all in memory. It can aggregate data on column-based, but it can also batch it in a certain area and flush certain computations already to disk and pull new data in. So it's quite clever in that sense.
Yeah, in that regard, if you do, I want to know you have cities and names here and countries. If you want to get the number of cities within a country or something, you only need city and country. And you do not need to read all the other columns. Like it can be a super big table of hundreds of gigabytes, but maybe the city and column table alone, there may be 100 megabytes or something, right? And then it would be smart enough to read only those columns.
Yeah, correct. And then the second part I already mentioned, it's simple. It's a binary or it's one pip install, and it gives you quite some things out of the box. And to illustrate this, I'm gonna try a demo because I think it shows better than me just saying it's simple. To basically show it, the demo, the data model I'm going to use is a typical shop. So you have some products and customers who want to buy some products, so they create an order, and an order has multiple items in it, which are the individual products they buy. So that's just a bit of context. So let's switch over to my terminal. Let's source the correct environment. Let's see which dependencies have I installed in my virtual environment. You see, well, I just have DuckDB installed. All the other things are used for my PyVim, just to show the Python code a bit better in my terminal. So I just installed DuckDB, and then I can open a shell. I can do import DuckDB. I hope you can read this. Otherwise, just give a shout. And that's basically all there is to it. Now I can start just writing SQL. So I have some CSV files I want to process. So let's see, I have the raw items, for example. I'm going to use read CSV, and that's in data raw items.csv, and it has a header, yes, and I want to auto detect the types. So it's, let's say, very simple. Let's hope I didn't make a mistake. Of course, I made a mistake here. That doesn't make sense. Okay, so very simple data set. It just shows the products, the orders it's linked to, so the individual items. Well, this is not anything spectacular. I didn't do anything with DuckDB. Well, it ran the query, but it didn't store anything yet. So now let's see. Let's try to do a very simple transformation, and let's convert this CSV file to Parquet. I'm gonna start with that. So let's create a view out of this. It's the raw items. Okay, so this view now exists within my DuckDB database, which runs along with this Python shell I've opened. So I can now say, well, okay, I can query this, of course. I can query this view, but no interest there. And I want to export this data, of course. I had as input CSV files. I want something out of it, not just in my DuckDB database, but I want some files out of it. And typically, well, we typically work with Parquet. So let's convert this CSV to Parquet. So how do I do this? It's very easy. So I'm gonna copy the input of this this view to Parquet. Okay, so this was not really exciting. You don't see anything, but it is there. Let me show that. Let's go out of here. Let's see what's in the out. And you see the raw items. I wrote it just this minute. So it's a Parquet file. Well, what's in there? Well, it's binary. You can't easily read it. Often also a minor annoyance if you want to download a file of blob storage and want to analyze what it is. Well, you could use just DuckDB to query this data. I have a small Python code, but you could also use the shell just to show what's in the raw items file. And if I show the code, well, it basically does a select star of the Parquet file I'm going to output. So for me, this shows two things. You don't need a lot of things to get started. It's easy for, in this case, let's call it exploration. I made some manipulation, I did some transformation, then I want to see what the output is because it's different than I expected. Or I just want to validate whether it's the same as I expected. Of course, you could say this is local. I could do this in Bandas. Yes, that's true. So let's make it a bit more tricky. Let's say I'm going to use the same files, the same CSV files, but now they are residing on S3. So I copied them to S3. What needs to change in my code? I just prepared this because otherwise it would take too long. So what do I need? I basically just need, as a dependency, also still DuckDB. It's the only thing. Of course, my credentials of my AWS account. And what do I need to do? Well, I need to install an extension, the HTTPFS extension, which basically implements the FS spec, which makes it possible to interact with S3, but also with Google File System, for example. Only Azure uses a different one, so that's you can't use that. But typical anything with that spec, you can use it, and then you can just start writing SQL. It's exactly the same. Instead of a local path, you give it an S3 path, and you can do the transformation. So I read the items in, I do some renames, then I read some raw products, I do a rename, I add some columns to indicate whether it's a food or a beverage. Very simple. And then the last thing is just joining the two raw input tables and doing a small aggregation on it, basically counting for every order how many food items do you use, how many beverages do you use. So
that's funny because I just received a question. So can you demo it to read data from S3? So.
Yeah. So well, and for me that's really nice. Just showing that it actually executes and that it works. Because well, might be that some people are skeptical. I'm not showing things that don't work. So you see that the DB output is just written. Let's. Maybe as a comparison, and I like that because, well, it shows a couple of things to compare it to Polars. I think I could have used Pandas, but I used Polars here just to see what are the differences. So Polars, you could also just import it. You have a bit more dependency because Polars, out of the box, doesn't come with an interaction with S3 or...
For those of you that are... Yeah, I have to shout, by the way, because I muted my mic. There was some interference.
Okay.
But for those of joining who don't know what's the difference between polars and pandas?
Yeah. Well, polars and pandas, polars is a newer version, and it basically it adheres more to the Spark API instead of pandas. It's written in Rust, so it's high performance. It's faster, but it's in my opinion more tailored towards people who like the Spark API. They typically tend to like polars more. Other people who are used to pandas, they will probably like pandas more. But in essence, the way you write code is very similar, and also with Polars 2.0, the mechanism of storing and querying data is also a lot more optimized now, and I don't know if there really is a big difference there.
Okay.
Yeah. So what do I need additionally, outside of the Polars dependency? I also need a way to interact with my S3 blob storage, of course, my credentials. And then the bit annoying part is, well, how do I start working with the CSV files? Well, initially I download them. I need to know a bit how to interact with S3 to be able to get this CSV file, and then I can start. Basically my Polars operations. Read this CSV file in, rename it, and that's the same as it is before. So if you look at this code, in my opinion, looking at the raw transformations, it's very similar. Right? It's very readable as well on top of SQL. I think a lot of people who know SQL will be able to read this. There is no rocket science there. Writing it, of course, you need to know the API. So it's a bit bigger hurdle. For me, the biggest hurdle is that, well, you need to have the intricacies of how to interact with S3. You need to know a lot more about that, the S3FS as a library, how that works as well, or AWS Wrangler, which is another option, which makes it a bit more brittle, or makes the bar a bit higher to get started with or to understand it. And then writing the data out is, again, you need to know how the different libraries work together and how you can use them. But overall, purely on the transformation side, there is not much to it. It's very, very, very simple. Okay, so I hope I gave you some insight in how simple it is to get started with and how you could use it. Okay, so then the third aspect, so I had three aspects of the vectorized query engine. It's simple to get started with, simple to install. And third, it's free. It's licensed under the MIT license, which means that you can change it, update it, you can make all kinds of changes, you can incorporate it into any product you want without having to pay a license, which is, I think, neat and also quite different than all the other databases that are out there, where it's typically licensed, strict licensing model. Either you pay a license or you can't make any changes or incorporate it in your product. I think DuckDB takes a very different route and say, well, it's totally free and everybody can use it, which I like, and also adheres to the adoption, which means maybe why it might explain why a lot of people are trying it out as well. Okay, so that was a short portion on DuckDB itself. So DuckDB can just do SQL. If you want to use it in your data pipelines, you can, of course, write these plain SQL files with your Python within Python. But I think, well, a lot of you and me included prefer then to use DBT. And DBT, the data build tool, it basically brings a lot of best practices of software development towards writing SQL. And I see it as, well, you can write your SQL, you have some templating logic, which also makes it possible to reference certain models. And so you don't need to create huge SQL files, but you can split it up in certain steps, and you can reuse those steps in multiple places. So that's my very high level introduction on DBT. It's not the goal to go in depth here. There are better talks on that. What I do want to focus on is, well, if you know DBT, what do you need to do or change from your DBT code to be able to use it with DuckDB? And of course, like with any database, you need to have an adapter installed. So you have a DuckDB adapter. The one that I show here is written by Josh Wales. It's the most popular one. It's also one I worked a bit on, and I like it. And it has the necessary tooling involved that you require to write a DBT project. Well, in my opinion, at least. So what are the two important configuration files that always exist when you write DBT? Of course, you need to change your profiles.yaml, and then you have your dbt project.yaml, which contains some specifics to this adapter. And I'm going over this specifics a bit. So one of the things you need to write, so of course it's a DuckDB adapter, that's clear. Where do you want to store your internal representation of the database? You can mount it on a certain path, mount it as a file to be able to reuse it if you restart it. The database is still there. You don't have to, but you could. You have the extensions, and like I said, you need the HTTPFS extension to be able to interact with blob storage. So that needs to be active. The Parquet one is by default active, I think. So it's actually not necessary to write it. Then the use credential provider, that's a nice one, I think, that we added, is that it basically allows any mechanism you have with AWS to authenticate. It supports it. It uses both the tree behind the scenes, so you can use any mechanism. You could use a secret key and an access key, like I did in my example, but you could also use web identity tokens, etc. So it's a technical detail, but it makes it usable also in a cloud environment. And then the external route is basically the base path where the output of your external models are written to. If you don't specify the output, dbt by default infers it, and this will be this location plus then the file name that you use. So then you don't need to specify it with every model. I want to write this to here. It has a default. So that are the specifics with DuckDB. They have quite some other options, but they are in beta. If you want to integrate it with Glue, for example, that support is still in beta. It works. I tested it out, but I wouldn't recommend it yet in production. But it's good to check if you are working with Glue at least. Then the other configuration before I go into the project is the dbt project.yaml, and there is one specific option I want to spend some time on, which is very specific to DuckDB, and it's the Onstart option. And the Onstart hook, you can specify register upstream external models. Well, this is, of course, it's specific to DuckDB. And why is this specific? As I already mentioned, DuckDB runs in process within your job, but that also means that if your job finishes, well, all the state you have typically gets lost. You typically write it out as an external file to S3 somewhere. But if you would split up your ETL transformation in a staging area and then a Mart that uses this staging layer, and it would be two separate jobs, then of course, if your Mart starts, the models that you created in the staging layer for DBT, they don't exist in your database yet. And that's what this hook does. It registers these staging models as well based on the output files you've written. And that means that you can split up your full pipeline in multiple chunks. You can use it per model or whatnot, and it will register the necessary upstream models, which is really neat, because otherwise, if this wouldn't exist, the only thing you could do is run everything, your DBT project, completely all at once. And you from your sources to your data marts all at once in one job, which defeats a bit the purpose, and it makes sense to split them up. It makes it easier. So that's an important option to have. So let's now dive into the demo project I created. All the code I showed in this webinar, it's all available on GitHub as well. So you can freely browse around with it later if you need to. So I have this coffee shop, the same model as I showed before. It's DBT. Let's see. So there's really nothing special on this DBT project. And you see the relevant structure. I have some models. So what do? So I start from some sources. So let me show the sources I have. And you see that are basically the CSV files I talked about earlier. So the raw items was the one I used in the previous example. So it's one of them. So I register it as sources. They are all on S3. You see it's the same read CSV auto. It's very similar than what I showed before. It basically reads the CSV files and makes them available. And then I have a staging layer. And in the staging layer, I don't do much. I just rename certain columns to make it easier to understand. I remember that, for example, it uses the SKU label, the SKU column, which is not really very explanatory. So it's basically the product ID. So just some renaming, some minor things there. So I do that for any of the sources. I clean it up a bit. And then the last part is my mart, where I basically want to do the actual interesting, I want to derive the actual interesting insights. And for example, I have here some SQL. It's based on what I showed before. So it basically parses or it calculates the summary of an order item. It does the aggregation on counting how much food items are there in an order, how much drinks are there in an order. So, but this is plain SQL. It's exactly the same as you would write any DBT code. It uses common table expressions and then writes it out. And then the only important aspect for you to remember is that on top, you need to specify all the data you want to have outside, or you want to write to a file. You need to make sure that it's materialized as external, which is something that the DuckDB adapter uses to define whether the table is only stored within the database or it's also written out as an external file. So with that materialization, all this output will just be written by default as Parquet files to the correct directory.
And so when you define it as external and then you read it in a later stage, does the DBT adapter know because it's external, I automatically read the Parquet file, or do you need to do
something? Yeah, so that's the register external models. Then it knows that model and it knows the reference to the external data, and it can use it. Without that, of course, indeed, it wouldn't work, because it would just say, well, I don't know this staging model you created before. Yeah, indeed. So that's the trick, and that's why this hook is very important for that. Okay. So this is a very simple DBT project. Now you could say, well, okay, this is very, very basic. I just processed tens of megabytes of data. I could use anything for that. And that's true. This is just to showcase a bit what are the best practices. You can read it more in depth if you want. But that's why also in my blog post, I wanted to do some benchmarking. I wanted to compare on an actual data set which is relevant, which it's the TPCDS benchmark, so it's a typical benchmark that's often used to compare performance of databases. And I adapted it to use DuckDB, and I used the input data is about 100 gigabytes of data. So I used the scale factor of 100. People who know this benchmark, that's the scale factor I use. And so the input data is 100 gigabytes, and I want to process it with regular machines, which are 32 gigabytes of RAM, 4 vCPUs. And I wanted to run all the queries that existed. It's a list of 99, and basically compare the performance against Spark, which was the first one. I'll do a follow-up with Trino, DBT, and as well, just to see how it compares with those. But the comparison with Spark was a relevant one. So what is the setup here? So I have on one side, you have the input data, which again resides on S3, which is the same as what I showed before. It's of course Parquet files now, not CSV files. You have the queries that are defined. You can find them also on this GitHub page. That's the one I created. And I try to mimic the setup both for Spark and DuckDB to be relevant. And so I use the same size of machines. I use the same setup. It runs in a Kubernetes cluster. So it pulls in that data from S3. It does the transformations, and it writes again the output to S3. So that's the same in Spark and using DuckDB. The only thing, and there was some confusion in my initial blog post on why I attached storage to it. Well, both of these technologies, they typically use storage for writing intermediary data. And in my Kubernetes pod, I typically don't have enough storage available for processing these tens of gigabytes of data. So Spark uses it to shuffle certain data around, but DuckDB uses it to store its internal data as well. So that's why I attach the same disks in both cases, just to give it an even playing field. But no mistake, the data comes from S3. It's not that I pre-populate the DuckDB database immediately where it can do the processing. It reads from S3, processes it, and then writes back to S3. So for me, that's a very fair comparison. It's not perfect. There are some tweaks that could be done, but it gives some idea. And here I show a certain amount of these queries. In the repository, you will see timings for all the queries. I ran it for everything, but it would be a bit difficult to understand. And you see that DuckDB comes out fastest in all but one example, and that's query 64, which is the heaviest query. It joins basically two fact tables together, and I think that join is not performant in DuckDB, or I need to give it more of a hint, but I didn't test it out, so it doesn't complete there. It goes out of memory, where Spark does successfully process this query. If you see there are 3 entries for every Spark, that's because I use different setups for Spark just to give some ID. I use a local Spark where you have a driver and an executor running in the same machine, and then 1 or 2 executors where it's a driver and then 1 or 2 executors, and give the timings of those, just to give you an idea. This is mainly to showcase that, well, DuckDB for medium-sized data sets in a lot of cases is more performant than Spark, which is completely understandable because Spark is actually built for handling a lot larger volumes than this. But this is to illustrate that, well, if you have medium-sized data sets, performance or efficiency, DuckDB might be a better fit than Spark. So could Bandas 2.0 as well. I didn't compare it to this yet. I could do that as well. But this is an illustration that for performance, you could argue with to use dbt and DuckDB. So that was actually all I wanted to show today. Quick recap. So when would you use dbt and DuckDB? Well, if my data resides in a data lake, if I have a medium-sized data where, as we discussed a bit earlier, let's say your input data you want to process is less than 100 gigabytes, then you can use it in your ELT pipeline, or do some ad hoc analysis. As I showed with the initial example, just reading the parquet file, doing some quick iterations to process it and see how it goes. In my opinion, it works, well, at least on my local machine, it works quicker than using Pandas, but that's maybe just a flavor. Why would you use it? Well, it's simple to install. It has almost no dependencies. It's just SQL. You just write SQL, and it has good integrations with external storage as well, with blob storage, but also Iceberg support is coming, and it's free to use for any product, etc. So that was it. I hope you learned something.
All right. With that being said, now I muted you for a bit and unmuted me. Apparently, there's some inference between our mics, so I hope you can hear me well. We're going to go over a few questions that I got on the comments, but also on Mentimeter. Thanks a lot, Niels, for this engaging talk. I'm looking forward to your polars comparison as well. So, well, maybe one thing was more of a remark than a question, but Matthias mentioned that for polars, you could have used PyArrow to interact with S3, which is a lot fewer lines, he said, instead of.
Yes, yeah. I could use PyArrow, yes.
Yeah. Okay, good. So just as a, yeah, somebody asked if the presentation is available. Yeah, we'll make sure you get it. But how do we get it? We can send it if you registered for the webinar. We'll send it to everybody who registered, and then you can see it. Maybe we'll also post it on LinkedIn or somewhere. So try to follow us. Then a few other questions here. I think there's one that we already more or less answered. Like, what is the difference between what would you call small data, medium data, large data? We already said that there is no exact cutoff point, but as a good rule of thumb, I think if you go above 100 gigabytes, then we would consider it large data for at least for this. Medium data is anywhere in the range of gigabytes, I guess, and then small data somewhere like megabytes, kilobytes, stuff like that. Yeah. So that was quite easy. Even I could answer it. Some more difficult questions for you. Do you know if there's an extension to read or write Delta files?
There is no extension within DuckDB itself to read or write Delta files. But what you could do is similar to what Matthias said. You could bypass it by using the PyArrow format. So you could read in Python your Delta file as PyArrow, and then use that in DuckDB to pull it in and process it there. So it's a bit of a workaround, which, well, it's not that clean, but it is possible because they use the same zero copy semantics that you can use to go back and forth. But at the moment, I think there is no support yet to natively just query Delta files.
Okay. Next question, I'll move back like this. What is the best way to work together in Parquet files with multiple researchers regarding storage, DB, lake, and organization? A SQL as model and multiple connections pointing to Parquet, question mark. So if I understand this question correctly, it's okay, now you've shown how you can do it yourself and how you control basically the end-to-end flow, but if we both want to work together on tables with DuckDB, is that possible, and if so, how?
Well, with anything with DBT, you could say DuckDB just lives within your Python process. So, and Python process could be just DBT running it. You could just, well, if you want to experiment yourself, I would just say, well, you have different profiles where you can say, well, for my local development, I use a certain prefix, or I use a certain path which you ingest as an environment variable or something, to basically distinguish your output data from the other ones while you're playing with it. Just distinguish the environments that you use. So you have playground environments for every user versus on production, it's a dedicated profile where it writes to a specific path always, to distinguish both of those. So that's what I would use. It's very similar to any processing you would, I think, do. The same problem would occur with any transformation logic in Spark as well, or Bandas, etc.
All right. With that, we just have 1 Mentimeter left for you to ask. How did you rate the session today? So did you learn something new? If you go back to Menti, you will see it. Did you learn something new? Was it easy to follow for you? Did it fulfill your expectations? Is it what you hope to get out of it? Was there a good mix between theory and examples? And finally, would you like to start playing with DuckDB yourself after this webinar? I'm going to share the results on the screen. Okay, so this is the first answers coming in. Yeah, I'll give you some time to complete this, and then we're going to wrap up. Niels, thanks again. Thanks a lot for this very engaging talk. I think you triggered quite a few people to start playing around with DuckDB, and I'm pretty sure fast forward 1 year, 2 years, it will be much more common tool set for many data engineers. So with that being said, thanks all for following along, and I hope to see you in the next webinar. Take care, everybody.
Bye.